whether these values are existing or not existing. Let me check it. This is 0 2. Again 3 into x raised to 1.3. Here it is 0 to 1. 0 to 0 we have taken in between a point, a single point. So what is the value of this function? At 0, 0. So at minus 1, at lower limit, if I substitute, it will be positive. Because it is negative value. 1.3 is the odd number. So we can say this is 3 only. 3 x raised power minus 1 whole power 1.3. And lower limit, if we take q root of this is q root 1.3 of minus 1. Minus 1 of q root is minus 1. This is positive value. And then plus sign. Upper limit, this is 3 only. Because 1 q root is 1. Okay, and then it is 0. So first is 0. 0 minus this. That means this is 3 positive. Plus 3 it is equal to 6. The function exists in between. And having the value this. So does the improper integral exist? Yes, it exists. It exists, and the value of this improper integral is 6, and the value is 6. So this is the answer here. So this exists. Yes, it exists. Question number 6 exists. Okay, because its value comes out to be 6. It's a positive value. It is existing. So this improper integral exists. Now let me talk about the next question. What 7th question? Now question number 7. What does it mean? Question number 7th here. Okay, so does the improper integral plus 1 to infinity dx upon x square exist? Let me check it. This is 1 to infinity dx upon x square. Okay, dx upon x square exist, and this is okay, exist or not exist, that is the question. 1 upon x square. So integration of this will be minus 1 upon x here. So integration, let me write here 1 to, let me take epsilon here, okay, or 1 to 0, even if I take, or 1 to 2 or any x1 value, let me take minus epsilon. This is x1 minus epsilon. Okay, and this is 1 upon x square into dx plus sign. This is x1 plus delta. x1 plus delta if I take, and this is infinity. Okay, and this is 1 upon x square into dx. So what is the limits here? Where limit epsilon turns to 0, delta turns to 0. The limit here, limit epsilon turns to 0. This is minus 1 upon x here, integration minus 1 upon x. Why? As x to be taken into the numerator, it will be x raised to power minus 2. Integration will be x raised to power minus 2 plus 1 upon minus 2 plus 1 divided by the index, whatever index is obtained. Minus 2 plus 1 is minus 1. Dividing by minus 1, that means minus 1 upon x. Okay, so limits now 1 to. Here, if I take epsilon equal to this, it will be epsilon only. Let me take this is x1. So the epsilon turns to 0, delta turns to 0. Okay, so this will be only x1. Or let me take here epsilon 0. Okay, so this is also minus 1 upon x, same value. This is limit x, delta turns to 0. In that situation, it will be x1 only. x1 plus delta, and this is infinity. What are the values? If I take, suppose this is x1 only, it will be minus 1 upon x1 because epsilon turns to 0. Minus 1 upon x1. Minus plus in between. When we substitute the lower limits, so it will be plus 1 sign. This is 1 upon 1. Here it is minus 1 upon infinity. This value. Okay, and again this is minus 1 upon x 1 because delta tends to 0. Minus 1 upon x 1, sorry, minus 1 plus 1, sorry. This is minus 1 plus lower limit. Lower limit is x1 delta tends to 0. In that situation, minus x 1 upon x1 plus 1 upon x1 cancelled out. This is 1 minus 0. Okay, so it exists. The value is 1. Does it exist? Seventh question. Okay. Does the improper integral exist? Yes, it exists. Yes, it exists. And the value is 1. And the value is 1. So this is answer. One value is there, function exists. The total value comes out to be 1. That means function exists. At least at one point it is existing, so it is equal to 1. Okay. This is existing. Question number 7 we have done. Now let me talk about 8th question. What about question number 8? Let us check it. Okay. Question number 8. What did it say? Question number 8 is, it says show that minus 1 to plus 1 dx upon x cube exists in the Gauss's principal value sense, but not in the general sense. That we have to just talk about. So if I take this question number 8 here, it means this is minus 1 to plus 1 dx upon, this is x cube here. Okay, exists in the Gauss's principal value sense, but principal value sense it exists, but not in the general sense. If I take, okay, let me take in general sense. In general sense, in between, if I take minus 1 to x1, or it is 0 mostly, in this case it can be 0 only. So if I take it is equal to limit epsilon tends to 0. This is minus 1 to, let me take minus epsilon, because 0 minus epsilon is minus epsilon. This is integration, let me take x minus 3 power, minus 3 power are taken in the numerator, and limit delta tends to 0. This is what? Plus delta, 0 plus delta means delta only, and this is plus 1 here. And this is again x raised for minus 3. Still we are not integrated. Now after integration, let me integrate this. Integration of this will be minus 3 plus 1, that means minus 2. X raised for minus 2 upon minus 2 being minus 1 upon 2x square. Try to understand. Because x raised for minus 2 upon minus 2, that means minus 1 upon 2 into x square are taken the denominator. And this is minus 1 to epsilon, minus epsilon, where epsilon tends to 0. Epsilon, limit epsilon tends to 0. Plus sign, this is again minus 1.2 x square. Here limit delta tends to 0. What is the in general sense? Whether does it exist in general sense? Okay, so this value is minus 1.2 x square, and this is delta to 1. What are these values? If I take in general sense, means minus epsilon and delta both are different. That is not general sense. Okay, if they are equal, then that means these two values become same. It is 0, this is also 0. Minus 0 means 0 only, this is also 0. If epsilon equal to delta, then this value will be the same. In that case, it will be principal value. But in general sense, let me define that what the value of this. If I take minus epsilon, that means this is minus 1.0. That means minus 1 plus here, so 1.2 epsilon square. Because minus epsilon, we have to substitute this minus sign here, minus epsilon whole square. Or it should be 0 here, negative value. And this is minus, okay, triple negative. Because minus 1 is square, sorry, this will be plus sign here. Why? So it will be 1.2 only. Because minus plus, minus sign is already there. When we put the lower limits, we put negative sign, so that minus sign and this minus sign will be positive. But when we substitute minus 1 in place of x square, it will become positive. That will be only 1.2 positive value. Okay, so this is what you call 1.2 only. Now what about this? Minus 1.2. First value will be minus 1.2. This negative value. This is minus 1.2 here is 0. Then delta. This is minus 1 plus 1.2 delta square. If epsilon square 0, delta square 0, in that situation these two values are not cancelled out. Okay, this is negative infinity plus infinity. In that situation, in case of general sense, it does not exist. So this is cancelled out, but this is minus 1.2 epsilon, because epsilon is not equal to this. This is negative infinity plus infinity. It means that value does not exist in general sense. So that the exist in the principal coefficient, but not in general sense. So in general sense, the values are, this is minus infinity because epsilon tends to 0, and delta also tends to 0. This is minus infinity plus infinity. Okay, so in the general sense, because so in general sense the value does not exist. The value of this improper integral does not exist. Means in that situation this infinity, this is infinity, plus infinity, minus infinity, no problem. But this does not exist in that situation. In that situation, because limits, if I substitute epsilon tends to 0, delta tends to 0, but before that these two values are different. This is 1 point infinity. 1.0 means infinity, positive infinity. This is minus infinity. Hence the value does not exist. Does not exist. What about in principal sense? Let me talk about in principal sense. But in case of when epsilon is equal to delta, we have taken this. In that situation, it will be 0 only. Okay, or before applying 0, these two values will be cancelled out. Why? Because before applying the limits, this will be minus 1.2 epsilon square, and that will be plus 1.2 epsilon square. These two are cancelled out. Okay, so this value equal to 0. In that situation, the function exists, means these two values. In that situation, this is minus 1 to plus 1. This is minus 1.2. This is also minus 1.2. Sorry, these two values will be added. This is negative. I'm sorry. This is minus 1.2. This is also minus 1.2. The value will be minus 1 in that situation. This is minus 1, but in that situation, these two values were in infinity. Whereby infinity not defined. But in this situation, okay, so the value will be, I'm sorry, let me write. This is minus 1.2 into epsilon square. It will be minus 1.2. Why? Because in this situation, minus 1 x in place of x, it will be plus 1.2. Minus 1 upper limit we have to substitute, but in case of lower limit, that will be plus 1.2. This is that's it for this is plus 1.2 because minus 1 is lower limit we have to substitute. This is plus 1.2. Okay, and in the first situation, it is minus 1.2 x square, so it is minus 1.2. These two values are cancelled out. Okay, so but this is 0 in that situation. This is not infinite. It means the value is existing. Okay, is equal to, even if it is 0, the value exists. Means it is not infinite. Infinite means does not exist. So in that situation, this is plus 1.2 epsilon square, because epsilon equal to delta. These two values will be cancelled out before applying the limits. Before applying the limits, the value will be cancelled out. This is 1.2 because lower limit is minus 1.2. This is x square here. I'm sorry, x square, but it will be positive. Minus lower limit. This is minus plus 1.2, This is the upper limit 1.2. First, it will be minus 1.2 only. These two are 0. In that situation, the value will be 0, but it means infinity is not there. So in case of principal sense, so in principal sense, this epsilon, these two values are already cancelled out before substituting the limits. Before substituting the limits, did not before substituting the limits. Okay, minus 1.2 epsilon square and plus 1.2 epsilon square are cancelled out. So it is not infinity in that situation. Infinity is cancelled out. That means in case of principal sense, the value exists, but not in the general sense. So that this exists in the Cauchy's principal value sense, it exists, but not in the general sense, because in general sense the value are infinity. Okay, so that is what we call exist in principal sense, but not in general sense. Now let me talk about 9th question. What is 9th question say? Let me talk about that also. Question number 9 in this situation. Does the, what does it say? Does the improper integral 0 to 1 this exist? Let me talk about this. This is dx upon x raised to power minus a half into ds. Okay, so integration of this will be, well, this is dx upon under root x, 0 to 1 limits. Does the improper integral this exist? Let me integrate this. This is 0 to 1. Okay, so integration, let me directly do this. Integration of this will be x raised to power minus half plus 1. This is plus 1 upon minus half plus 1. That means it is twice x raised to power and limits 0 to 1. Okay, even if we take, okay, in between x1 point, at x1 point we can take, but before that let me directly do this. Integration is minus half plus 1, that means plus half, it will be twice x raised for plus half, limits 0 to 1. It exists with 2 into, okay, because x raised power 1.2, this is twice only, because at 0 it is 0. 2 function exists. Yes, it exists in this limit. This exists, and the value is 2, and the value of the existence is 0, or the improper integral is 0. The value of this is 2. This 2 is the answer here. Question 9 exists. This improper integral exists in this interval, this limits, finite limit 0 to 1. So, but in case of finite limit, the function does not exist. It says it is improper integral of second kind, because this is of improper integral. Undoubtedly, finite limits are there, but function exists in between. So this is a proper integral. You cannot say this is improper integral, because improper. This is improper integral, he says improper integral, but this function is not improper integral, because function exists and limits are finite 0 to 1. If the limits are finite, that means this is proper integral. In case of proper integrals, limits are finite and function exists, function is bounded within that limits. This is proper integral, not improper. Okay, so this is what you call improper integral. Now let me take the 10th question. What about 10th question here? Let me talk about that also. Today let me finish these, all the questions. Now 11th question, what is, 10th question, Now question number 10th. Now here it says, does the improper integral this exist? Let me check. 0 to 1. It is dx upon s here. Okay, so integration of this will be log of x 0 to 1. Okay, it does not exist. Log 1 minus log 0 both are, this is 0, this is also not defined. So 0 does not exist. Does not exist. So this is of second kind, improper integral of second kind. Because function is unbounded. Function is integrand is unbounded, limits are finite. This is of second kind. Does not exist. This is improper integral. This is improper integral of second kind. Improper integral of second kind. Why? Because limits are finite. As limits are finite and integrand is unbounded, and integrand is unbounded. Second kind of improper integral, 10th question. Now let me talk about 11th. What about 11th question? Improper integral. This. Okay, 10th, 11th question now. What does 11th question say? Let me talk about that also. Okay, these are. Let me replace the markers. Okay, so now 11th question. What does it say? Now question number 11, it says, does the improper integral this exist? Let me check it. 0 to 1. Okay, and this is dx upon under root 1 minus x. Okay, so does it exist? It says. Let me check it. So this is nothing but, if I take x equal to, putting here, let me integrate this. There are finite limits, putting x equal to sine square theta. So differentiating it with respect to theta. With respect to theta. With definite integral, we can solve it by substitution. We can substitute here x equal to sine square theta. Okay. So dx is equal to 2 sine theta into cos theta into d theta. Why? Differentiating it with respect to theta. With respect to theta, we get dx upon d theta is equal to 2 sine theta cos theta. Cos first 2 sine theta. Sine theta is differentiated as cos theta. This is 2 sine theta into cos theta into d theta. We have taken that side. Now limits, let me change. At 0, 0. At 1, it is 90 degree. Okay, because let me write at x equal to okay 1 sin theta equal to pi by 2, because sin square theta is 1. At this is pi by 2, sorry, sin pi by 2. Sorry. At 1 equal to sin pi by 2. So theta equal to pi by 2. I'm sorry. Theta equal to pi by 2. Upper limit. Lower limit at 0, it is 0. At x equal to 0. Sin 0 is equal to 0. T equal to, sorry, theta equal to 0. So limits are these. Let me change these limits. 0 to pi by 2. And this is dx is 2 sine theta cos theta d theta divided by under root 1 minus sin square theta. This is cos theta here. So 1 minus sin square theta is equal to cos square theta. Cos square theta square root is cos theta. So cos theta cancel out. The value will be twice 0 to pi by 2 into sin theta into d theta. Sorry, sin theta d theta. Integration of this will be 2 into minus cos theta. The integration of sin theta is minus cos theta. This is 0 to pi by 2. Okay, so at twice, this is minus cos pi by 2, 0. Minus plus here is 2 into cos 0. Cos 0 is 1, this is 0. Plus 0 plus 2 into 1. Cos 0 is 1 here, this is twice. Okay, so this exists, value is 2. So if this function exists, does the improper integral this exist? Yes. Yes, it exists. And the value is 2. And the value of it is 2. Value comes out to be 2. So it exists. Value is 2. The function, this is 11th question. We have done. Improper integral just, okay, limits are infinite, function does not exist, bounded, not bounded. That just we have to check on it. Okay, and even if limits are finite, sometimes function is not bounded. That means second kind of improper integral. And of what kind of improper integral, that we have to just check. Okay, now let me talk about the next question. This is 12th question now. Question number 12, what does it say? So that -1 to 2, okay, this is -1 to 2 dx upon this is x cube exists in the Gauss's principal value sense, but not in the general sense. Again, this kind of question we have done in the 8th question. Here limits were -1 to +1. Here limits are -1 to 2. No problem. So let us take -1 to +1 and +1 to this. So that can be done. So let me take the limits -1 to +1 minus epsilon. This is x raised to power -3 into dx plus this is 1 plus delta. Your limits delta tends 0. Limits delta tends 0. Here limits epsilon tends to 0. This is definition of Gauss's principal value theorem, sorry, general value theorem. And this is 2 here. And this is x raised to power -3 into dx. Here limits are -1 to +1, sorry, +2, -1 to 2. In between we have taken 1, 0 to -1 to 1, then 1 to 2. Okay, but here minus epsilon plus epsilon. If I take before applying the limits, let me substitute the value. Integration of this will be minus x raised to power -2 upon -2. That means -1.2 x square negative value. Because this is the limit epsilon tends 0, and this is -1 to 1 minus epsilon plus sign. Okay, here again this is -1.2 x square limits 1 plus delta to here limit delta tend to 0. Okay, and this is 2 here. Okay, so if I substitute here where epsilon tends to 0, it is 1 only. Okay, so let me first write 1.2 into 1 minus epsilon whole square. Okay, 1 minus epsilon whole square, and then plus sign, and here limits epsilon tends to 0. Okay, before applying the limits, this is the limit epsilon tends to 0. Second case is -1 limit. If I apply, we -1 plus here 1.2. -1 is square is +1, +1 only, and plus, but this is -1 here. This is -1.2 into 2 square. Okay, -1.2 into 2 square, and this value will be plus limit delta tends to 0. Okay, and this value is 1 upon -1.2 into 1 plus delta. I'm sorry, this minus lower limit, if I substitute, it will be minus plus here. And so this plus sign we have taken. Okay, this is -1 delta whole square. This is 1.2. Let me write clearly. Let me write it here. Plus sign. The -1 plus 1.2 into 1 plus delta whole square, and this is limit delta tends to 0. Now here it is minus sign. Okay, and here the value is 1.2 square, that means 1 minus 1.8 plus 1.8, the value is lying. Okay, so if it is 0, show that the value this exists in the Gauss's principal value sense, but not in the general sense. Okay, so this we have to show. Okay, so in this case this is minus 1.2, 1 minus epsilon. If epsilon tends to 0, suppose, before that these two values are not cancelled out. Okay, they are different values. If it is 0, this is minus 1.2, this is plus 1.2, this is cancelled out. Then the value will exist. This is opposite of this question. Okay, so that the minus 1 plus 1 dx upon x cubed exists in the Gauss's principal, but it exists. It does not exist in case this, if epsilon tends to 0, these two values are, if it's 0 suppose, it means minus 1.2, this is plus 1.2, these two are cancelled out. Then this value will exist in general sense. It's the opposite question of this. The value is existing. So before applying this, or even if epsilon tends to 0, it is the 1 only. So minus 1.2, this is plus 1.2. These two will be cancelled out. And in case of this is 1.2 plus 1.2 here in the lower limit. And this is minus 1.2 because this is x square here, not. So x square means 2 square. This it will be 1.8. 1.2 minus 1.8, that means the negative positive value, because this 2 4 the 4 minus 1 is 3 upon 8 value is coming. Even in principal value sense, or general sense, the value is existing, because even if I take delta or 1 even, these two values will be cancelled out. The value is still lying. But the limit is to minus 1 to 1, if it is there, then these two will be cancelled out. So that in that situation it will not exist, but it exists in general sense also. Okay, the function value is existing in general sense. It's not true that function is not existing in principal value sense. Okay, it exists in general sense as well. So it exists in general sense as well. Because function is having a definite value, which is 3 upon 8, sorry. 3 upon 8 value is coming out. If we substitute 0, in that situation those two values we cancel out, but 3 upon 8, the value exists in general sense. Okay, so even after applying the limits, the function is applying this exists in general sense only. Okay, principal value sense, even principal value sense, if we